video on chemical equilibrium part 1 is brought to you by Academics World, a new way of learning. So before going ahead with our chapter, let us think about when we hear the word equilibrium. When we heard the word equilibrium, immediately a picture will arise in our mind that something gets equal, etc. and all, or something two forces are equal and have same intensity. So here we are studying equilibrium. So what is equilibrium? Equilibrium is a state in which competitive influences are balanced. Uh, Here clear is given that competitive influence, for example, this rock has suppose 5 kg mass and this is 4 kg suppose, and they get balanced by this rock. So the way they are balancing and this state is called equilibrium. So the next example also is given here that a man of 50 pounds and this has 50 pounds weight, length is 10 feet, and they are balanced. So they are also at equilibrium. So now we study what is dynamic equilibrium. I will tell you the difference between equilibrium and dynamic equilibrium to the next slide. So first we study what is dynamic equilibrium. It is a condition of a system in which rate of forward reaction is equal to the rate of backward reaction, or it is a state in which concentration of the reaction and product is constant. So I am telling the difference between the equilibrium and dynamic equilibrium. Equilibrium means competitive influence are balanced and appear to be static. Static means stop, and dynamic means appear to be static, but it was going on. The process is going on, not stopping. And we know that dynamic equilibrium is a not ending process. So let us clearly understand what is dynamic equilibrium. It is a condition of a system. It is condition. I am giving you example, but first we read this definition, in which rate of forward reaction is equal to rate of back. So I am giving you example N2 plus H2 equilibrium sign. This is equilibrium sign. Please note N2 plus H2 NH3. So we balance this. This is an equilibrium reaction we have seen in chapter 1 this, and this is a condition of a system in which rate of forward reaction and backward reaction are equal. And now second definition, it is also same. It is state in which concentration of reactants and product remain in is constant. So I am giving you one more example. Suppose there is tap here and there is one jar and there is one more tap. Suppose this water is falling from this tap in this jar, and the speed of water falling in jar is 1 liter per minute, suppose, and this tap also leaving water at a speed of 1 liter per minute. So if you crucially observe that if water is entering in this jar, same amount of water is exiting from this. So the amount of water in the jar remain constant. So this is an equilibrium. It is a dynamic equilibrium. I I have explained you what is the difference between the equilibrium and dynamic equilibrium. Dynamic equilibrium means appear to be static. That means the process is appear to be stopped, but it was going on. I have proof for this. It was going on. For example, you have put this. For example, you start leaving first red water from there, and this get fully red, and this also leave red water. Then you start uh, giving blue water, then you see first red water get exit and then mix and then blue. So this is giving that the process is going on, not stopping at all. So now we we start to learn the types of equilibrium. We have two types: first physical equilibrium and second chemical equilibrium. First, we study physical equilibrium. Physical equilibrium generally is divided into five types: solid liquid equilibrium, liquid vapor equilibrium, solid vapor equilibrium, deposition of solid in liquid, deposition of vapor in liquid. We will study all this part in brief in next slides. So now the term comes from solid liquid equilibrium. I'm giving you one example of solid liquid equilibrium, that ice is floating on water at 0 degrees Celsius. Please note there is temperature 0 degrees Celsius. If you put ice on water in a glass, here is given here, and you will see that the amount of ice and water remains constant. So how this is happening? This is happening because um, 0 degree, we know that 0 degree is the freezing point of water, but we also know that 0 degree is the freezing point of the water. So that's why this is at equilibrium. But why it is dynamic equilibrium? It is dynamic because it is not there just that the word the ice remains as and water. It is not there. The rate at which the water gets freezed is equal to the rate of ice that melt to form water. So that's why this is an solid liquid equilibrium. So now the turn comes for liquid vapor equilibrium. So I have written here that if we heat water in a closed system at constant temperature, equilibrium. So let us consider the example. Suppose there is jar and you are heating this jar from here, and closed system means we are putting an plate or something tile on the open face of the jar, and the temperature is constant, for example 100 degrees Celsius. So here is water. Suppose it get heated and the molecules come around like this, suppose, and you will see that if you remove this plate, you get some drops of water attached to the plate. Why this is happening? This is happening because the suppose we are attaching here manometer. Manometer is used to measure the temperature, measures the pressure of the container, etc. And suppose here is the amount of 100 molecules of water. This is 100 molecules at 50 degrees Celsius, suppose, and these molecules that are now in vapor has 20 molecules. But when these molecules get attached with this plate, the water are also condensing and falling again in the water form. So minus 20. This is because minus 20 because the rate of water converting in vapor is the rate of is equal to the rate of water falling in this amount, so remain constant. But if you change the temperature, then suppose now water that in liquid state are now 80, and this molecule, we know that if we heat more than molecules vapors more 40, but also condensing 40, so remain constant 80. From that we understand that if we change the temperature, the equilibrium also get disturbed, and equilibrium arranged according to the given temperature. So temperature is one of the important factor that affect equilibrium. So now vapor solid equilibrium, it is very simple. We know what is sublimation and what is deposition. But I am going to tell you, and sublimation is only what is conversion of solid directly to gas. Directly, there is no liquid phase in this. And deposition is only what? Gas when directly converted into solid. So can you predict an example of vapor solid equilibrium? The example is NH4 Cl equilibrium. NH4 Cl. This is gas, this is solid. So ammonium chloride and this ammonium chloride gas, and this solid. This is a perfect example of vapor solid. But if it is a closed system, please note, equilibrium required closed system to attain the equilibrium state. So now the term come for deposition of solid in liquid equilibrium. Example of solid liquid equilibrium, deposition of solid in liquid. For example, this is one glass and water is filled in this, and you add sugar, one spoon sugar, then dissolve second spoon, then dissolve third spoon. But now if you try to dissolve the fourth spoon, it will not soluble in water. This is concentrated at lower part. So this is fourth spoon sugar. Why this is happening? This is happening because of equilibrium. We know that when we add sugar to water and mix it, it gets soluble. The empty space between the water molecule get occupied by this was sugar molecules, and when this empty space get full, they not dissolve this sugar. But how it is equilibrium? It is equilibrium because this sugar is not that sugar that the fourth spoon has. This sugar may be first, second, third. It is because as water, as the sugar that is dissolved before is converting into this deposit sugar, and this deposit sugar get convert into soluble, but the rate is same. That's why it is an equilibrium. So now deposition of gas in liquid equilibrium. Suppose we all drink colas, um, thumbs up, etc. So suppose there is one bottle. Suppose you see that when the steel bottle we have, there is gas filled with high temperature. When you open the cap, immediately gas comes out. How? How does this equilibrium? This equilibrium. First, I'm going to tell you some basic things about it. In this, gas is dissolved in solid, so that the this colas etc. don't spoil its taste. And when you open this cap, immediately this gas immediately comes out, because when this bottle gets sealed, it is filled at high pressure, and when you open, the low pressure get created, and molecules try to attain equilibrium according to the surrounding pressure. And surrounding pressure is generally 1 atm, which is 76 centimeter hg. So so from the above all these physical equilibrium example, what we conclude? We conclude characteristics of equilibrium. So equilibrium is attained in close temperature. I have given you example. Suppose this is jar and plate is closing, water molecules etc. I will explain you in second. Attained at constant temperature. I also gave an example of it. Suppose sugar dissolving it is, but food get not. If you heat, then sugar also get dissolved. Fourth also, because heat get temperature is the one of the main factor that affect the equilibrium state. Third, appear to be static, but it is dynamic. I have explained you that it static means stop. Appeared, but it is dynamic. It is going on inside, but appears to be stopped, etc. So coming to the fourth point, there must be an observable property like color, temperature, etc. There is one characteristic or observable property. Suppose color. I have given you an example of this. So a tap is, suppose this tap for water swallowing 1 liter per minute, and here also 1 liter per minute. So this characteristic. Fifth, equilibrium can attain from either side. How it? I give an example: N2 plus 3H2 equilibrium NH3. So if this reactant react this form, but if this NH3 get heated, then this get N2 NH2 gas form. That's all. Thank you. Please like and subscribe our YouTube channel. Thanks once again.